here's the overview of my presentation. First, I will go through some background information and before introducing the operator maturity model. And then I will talk about the significance of our project, what our main contribution is, and about our product called the new visitor side operator. And then an experiment will be illustrated to give you an understanding of how our product can improve the application performance, and then some possible areas for improvements. First, about application containerization. It is an OS-level virtualization method used to deploy and run distributed applications without launching an entire virtual machine for each application. So only the necessary components, only the necessary information to launch the application will be packaged into a single container. So in this case, the container can be very lightweight and portable. So it is a very important technology in today's distributed computing and cloud computing. So Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. And Kubernetes operators are just extensions to Kubernetes that make use of custom resources to manage application and their components. And here is a famous maturity model for the Kubernetes operator. You can see that here are 5 levels, and each level has some functions. So only operators that have some functions in that level is said to have reached that particular level. And the most basic level here, the level 1, is about installation. Operators should be able to install the managed workload. And it's a very basic function for basically all the operators. And the second level is about the seamless upgrades. The operators in this level should be able to upgrade and perform some minor version upgrades seamlessly, that is without any downtime or data loss. And the third level is about the full life cycle. Operators reach this level only if the application has completed its full life cycle. That is, it has some important features like data backup and restoration. And fourth level is more for the app maintenance. Application should be monitored when it is running, and also some useful alerts can be sent when some unexpected events happens, so that maintainers will have some idea about the running applications. So the last level is the Autopilot. It includes many advanced features, and the auto scaling is one that is very essential in today's cloud computing, and that is one we are going to focus in our operator. And that here's an very important here's an issue that we should focus on, because up to now there's still no operator managing a real case application that demonstrates the realization of each of the 5 maturity levels. So actually our work is the first of its kind to demonstrate the capabilities of Kubernetes operators at each maturity level. So hopefully our work can reduce the work complexity for the future developers and facilitate the construction of operators with more advanced features, because those developers can just directly reference our code, part of our code, because our code contains many basic features like backup and monitoring. So that is very important in today's operator development. And here we can first have a look at the application that we are going to manage using our operator. This application is called Visitor Site, and it has only one main page. You can see that in this page, we just have nothing more than app title and a table containing all the records about the visitors. So each time a visitor pays a visit to this web page, its record will be appended in this table. So each time you refresh your page, another record will be added to this table, indicating your service IP, client IP, and the current timestamp. So this is a very simple application that has only 3 components: front end, back end, and database, and they are developed using different softwares, as you can see here. The front end is just responsible for the web UI, and back end is just for interaction between the database, how it retrieve data from the database and display that in this table, and how it sends new data to the database once any new visitors pays a visit to the website. So this example comes from this book called Kubernetes Operators, and in this book, an operator that is used to manage these applications is introduced. It's called visitor side operator, and our operator is just developed based on this one. But in the original operator, here it's a very important operator development tool called Operator SDK, and it has many useful tools and functions to build a good operator. But actually, in the original version, the Operator SDK, its version is outdated now. So its code can no longer be used in the future versions. So in our new operator, we actually use the latest version of Operator SDK. And moreover, in the previous operator, only the functions in the first two levels of the operator maturity model is included. So it actually cannot do anything advanced like data storage. So you can see that if you just launch your application on a different computer, all the information in the table will be lost. So actually, you just cannot store your data, nor can you just do something like auto scaling or monitoring in those advanced levels. So our operator will just includes functions of all the 5 levels. So actually, it is more comprehensive. So let me first introduce my operator level by level. And here you can see that the first level is the basic install. It's very easy thanks to the built-in functions of Operator SDK. We just have to run a single command and all the necessary components will be installed. And here you can see that we can apply a custom resource to just install and configure all the workload. For example, for the front end, we just have to, we just want 1 pod, so we can just specify it here. And for the back end, we want 2. So yeah, you can see that all these attributes can be specified in the custom resource, and also including the front end title, that is the title on the main page. But in addition, the database cannot be installed in this way because we have to use an external MySQL operator to install the database, because the database has many advanced features like data backup and something like that. So that is very complicated, and its business logic is so complex. So we actually we don't have full understanding of that, but that is not necessary because we just need to use it. So we can just install it from using Helm, a package manager for Kubernetes. So we just install it and apply another custom resource to install the database cluster. You can see that here the database version as well as the number of database pods can be specified in our database CR. So the second level is upgrades. Upgrades is similar as install. We can just apply a new CR for upgrades. For example, we just change some attributes here, and then the system will be upgraded. But actually, what's special here is about MySQL version, because we do not want our system to experience any downtime or data loss. So actually, we can specify the database cluster to have at most 1 pod upgrading at the same time. So in this case, if our cluster has 3 pods in the database, we will have at least 2 pods working at any time. So actually, in this way, we can just avoid any data loss or downtime, because there are always some pods working. And yeah, and that's for the level 2. And for the full life cycle, that is the data backup, we can just have a cloud storage platform to achieve this goal. And AWS or Google Cloud Storage can all be possible options. And here we can just choose Google Storage, Google Cloud Platform as a remote storage platform, because yeah, it's just for demonstration. And here you can see that we can just apply a simple CR for the data storage. As long as you specify the remote URL here, you can just back up your data in the remote. And once you just want to retrieve the data, let's say you want to launch your application in a different computer, you can just specify another CR here using the same URL, and you can just retrieve the original data. And for the next level, the deep insights, we focus on the monitoring. And actually, there's a software called Prometheus that can just receive metrics from the Kubernetes nodes and API, as well as the database, MySQL database. And all these metrics will be sent to Prometheus. And once any rules are broken, the Prometheus can send those an alert to the alert manager. For example, if any pods are down due to some unexpected events, an alert will be sent to alert manager, which can further send notifications to the maintainer's email or other platforms like Slack. So app maintainers will have some knowledge about that. And also data can be sent to the Grafana for data visualization. You can see that here is an example Prometheus page. And once any error in the system takes place, Prometheus page will just display it so app maintainers can check it and also know about what is the reason of triggering that alert. And here in the Grafana, some important information can be shown in this page in a quite nice way, including the CPU utilization or the memory usage or something like that. Okay, and here comes the final level, which is the Autopilot. Because Autopilot has many advanced features, we just focus on one important feature called autoscaling. There are two kinds of autoscaling, and we focus on the horizontal autoscaling because actually vertical autoscaling is just give more resources to one pod or a node, but horizontal scaling will just allocate more pods or more nodes to a system if there is the load becomes heavy. And Kubernetes has a built-in API resource called HPA, Horizontal Pod Autoscaler, to do such thing, to do the autoscaling. The HPA will just listen to metrics given from Prometheus, and it will just link to another deployment, for example, a front-end deployment or back-end or a database cluster, actually any cluster that is scalable. So for example, if HPA listens to the CPU utilization sent by the Prometheus, actually when the one pod's CPU utilization has reached a threshold, it will just allocate more pods to the deployment. So in this case, the new traffic will be handled and the application performance can be guaranteed. Because here is an example to test. Here is an experiment to test the auto-scaling function of our operator. JMeter was used to stimulate the users continuously paying visit to our web page at the same time. So we want to test how fast the backend can retrieve the information, retrieve the data from the database. And actually, as you can imagine, if there are many, let's say 100 visitors paying visit to our website at the same time, the application performance will definitely be affected. The response time will actually increase because the lack of resources to handle the new traffic. But actually, if we have a mechanism like HPA, HPA will detect the increase of CPU utilization, and then it will just generate new pods to handle this new traffic. So you can see that here, the response time is measured using JMeter. And in this case, HPA is launched after the heavy load. In the beginning, the load is actually set at a relatively high level. Maybe many visitors paying visit to the website. So you can see that the response time is very high. And after launching the HPA detects that high level of pressure. So it generates new pods to handle this traffic. And then you can see that the response time reduces to a lower level after the new pods are generated to handle the traffic. And in the second case, the load is exerted after the HPA. So at the beginning, HPA is already launched. And after some time, we increased load to the application. And so the response time just dramatically increased, showing that there are many visitors paying visit to the website. But then the HPA just detects that change and generates new pods to handle this new traffic. And then you can see that the response time just reduced to a relatively normal level. So several improvements areas for our operator. We can possibly add new some Prometheus rules that is specific to the application to our operator. For example, instead of listening to CPU utilization, we can just listen to the number of visitors paying visit to the website at the current time. And once this value just exceeds a threshold, we will send an alert to the app maintainer. So other functions in the level 5, like the vertical scaling or other autopilot features like auto healing, auto tuning, and abnormality detection can also be included in the future. Yeah, and that's all of my presentation. Thanks.